Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to look at factoring trinomials whose leading coefficient is not equal to 1. In the previous video we looked at factoring trinomials that had a leading coefficient equal to 1, and today we're going to look at the case where we have a leading coefficient equal to a number other than 1. The process is a little bit different, a little bit more involved, but we will go through it step by step, and hopefully it's not going to be too difficult for you. So here we have an example, and instead of just looking at before we just looked at the coefficient of our constant term or our last term, in this case we look at this coefficient and we multiply them together. And that's the number that we want two numbers to multiply to equal. We still use our middle coefficient as the number we want the sum to be equal to. So we want two numbers whose product is 9 and whose sum is 10. So they have to multiply to equal that. They have to add. I'll put add there. We don't need to get fancy with the terminology, but sum does mean add. Multiply does mean, or product does mean multiply. So two numbers that multiply to equal 9, add to equal 10, those numbers would be 9 and 1. Then what we're going to do is break up this middle term into two terms with these coefficients. So I'm going to go 3x squared plus, instead of 10x, I'm going to write 10x as 9x plus 1x. Now what we're going to do is factoring by grouping, and that's typically what we do when we see four terms like this, and in this case we're going to factor out of these two terms, factor out of these two terms. So when I look at these two terms, I can factor out a 3x, and I'll be left with x plus 3. Here there's nothing common to those terms, so really the only thing I can factor out, or I can think of it as 1 times x plus 3. Because I know I want an x plus 3 there, I want an x plus 3, and I recommend that you put the 1 in there. If you don't put it in there, students often overlook it, and it's very important that you include it when you do the next stage of the next step of this. So when I then factor out the x plus 3, I'm left with 3x plus 1. That's where that needs to be, and if you don't put that 1 there, you may miss it. So I strongly recommend that you put it in the brackets. It just helps you see everything, I think, clearer. We can always check to see that our factors are correct by multiplying and seeing if the result is what we started with. So x times 3x will be 3x squared plus x plus 9x gives us our 10x plus 3. So we know it's correct. Now you may ask, did I have to do this order? Could I have flipped it? Well, let's see. Instead of 9x plus x, let's change the order, x plus 9x, and see what we get. So now when I factor these two terms, I can only factor an x out, so I'm left with 3x plus 1. When I factor these two terms, I can factor out a 3, and I'm left with 3x plus 1. This is the same as this, so I can factor 3x plus 1 out of both terms, and then I'm left with x plus 3. This is identical to what I got when I did it the first time, other than the order is different, which doesn't really matter. When you're multiplying, you can multiply in any order. So no, it doesn't matter which way you split them up. You should end up with the same result either way. Let's look at some more examples. My leading coefficient is not a 1, it's a 5. My constant is -6. So if I take 5 times -6, I'm looking for two numbers whose product is negative 30, and they're not necessarily going to be these numbers. So I'm looking for two numbers that multiply to equal negative 30 and add to equal negative 13. So we can play around with all the factors of 30. 30 is 2 times 15. This is prime number, this is not. So we break that down into its prime factors, 3 times 5. So 30 is equal to 2 times 3 times 5. And the reason that you might find this useful, especially when you get into numbers that have a lot of factors, is that it makes it quick to see the different factors. So for example, I have 2 times 3 is 6 times 5. I also have 2 times 5, which is 10 times 3. I also have 2 times 15. So it just gives you some of the options very easily when you combine those different factors. So we're looking specifically for two that multiply to equal negative 30. So one of them is going to be negative, one of them is positive, and they add to equal negative 13. And hopefully you can see that 2 and negative 15 are the numbers. They multiply to equal negative 30. They add to equal negative 13. Then we break up this middle trinomial, or middle term in our trinomial, into those two terms. So I've got 5t squared. I'm going to go minus 15t plus 2t. So notice negative 15t plus 2t, it's still equal to 13t. So I just broke up into those two, minus 6. So this is still equivalent to what I had. And now I'm going to factor by grouping. Out of these two terms, I'm going to factor out a 5t, and I'll be left with t minus 3. Plus, out of these two terms, I'm going to factor out a 2, and I'll be left with t minus 3. So if you've done the process correctly, you should end up with each term containing this same factor. We then factor that out of each term, so it'll be t minus 3, and I'm left with 5t plus 2. Do a quick check. T times 5t is 5t squared, plus 2t minus 15t gives me minus 13t minus 6. All right, so we're done. Okay, with this example, I have introduced two variables, so we have x's and y's. As long as this one is a square and this is a square and this middle term contains both, the process with our numbers is going to be the same. We just have to make sure we have an x in the first term and a y in the second term of our factors, of both factors, both binomials. So my first step is to multiply the leading coefficient with the last coefficient. So 2 times negative 7 is negative 14. So I'm looking for two numbers that multiply to give me negative 14 and add, multiply to equal negative 14 and add to equal negative 13. Those numbers are 1 and negative 14. So what I'm going to do is split this term into two terms having these coefficients. So I have 2x squared, and I'm going to go negative 1xy. Oops, sorry, it's a plus 1xy, and then minus a 14xy minus 7y squared. So negative 13xy is equivalent to 1xy minus 14xy. So I haven't changed any values. This will allow me to factor by grouping. So I factor an x out of each of these two terms, and I'm left with 2x plus y. Now the idea here is I want to factor something out so that I end up with this same common factor. So if I take a look here, I'm going to factor out a negative 7y. And you can put plus negative if you prefer. So if I factor out a negative 7y, I'm left with 2x in this term. When I factor a negative 7y out, in other words, take negative 7y squared and divide by negative 7y, I end up with plus y. So always look to see what this factor is to help you figure out what to factor out. Because if I would have factored out a positive, these two would have been negative, and then I couldn't have done my next step. So you want to make sure that these are exactly the same before you factor it out of each term. Now we factor it out of this term and we're left with x, factor it out of this term and we're left with minus 7y. Again, we can do a quick check. 2x times x is 2x squared. Minus 14xy plus xy gives me minus 13xy minus 7y squared. Let's do one more example. I wanted to do another example that had the power that was greater than a square, but I mean it's a square, but it's higher than a 2. So it's like p squared squared, but I have the p squared term there, so I know that I can factor this. The leading coefficient is not a 1, so I multiply 3 times negative 4 to get negative 12. So I'm looking for two numbers whose product is negative 12. This coefficient is a 1. Those two numbers that I choose must have a sum equal to 1. So there's two conditions. There's a lot of numbers that add up to equal 1. There's a lot of numbers that multiply to equal negative 12. But there's only one set of numbers that will meet both conditions. So we look at our possibilities, and the two that are going to work is negative 3 and positive 4. That's the only option. They multiply to equal negative 12. They add to equal positive 1. So I'm going to split this term into two terms with those coefficients. So I've got 3p to the 4th minus 3p squared plus 4p squared minus 4. So in my first two terms, I do factoring by grouping. I can take a 3p squared out, and I'm left with p squared minus 1. I do the same thing with the next two terms. I factor out, in this case, a 4, and I'm left with p squared minus 1. You're looking for these common factors, which I have. I can factor those out. So I have p squared minus 1 times 3p squared plus 4. I can check it, make sure it's correct, but I don't know if you've noticed anything here, but I now have a factor that can still be factored. And when you're asked to factor an expression, you're not done till it's totally factored. So you want to keep going with it. Make sure that you don't have anything that can be further factored. This can, because it's a difference of squares, so don't forget to complete those kinds of things. So I've got, recognize those patterns and then continue with the factoring. So the factors are p plus 1, p minus 1 times 3p squared plus 4. That's my final result. So that concludes all of the videos on factoring. Now what we're going to be looking at is algebraic fractions and certain types of equations where we're going to need to know how to factor. So practice this concept when you have a trinomial and the leading coefficient is not equal to 1. Make sure you understand it so that when I refer to it in the next videos coming up, you will have this skill down and you won't get lost in the factoring part. So practice, get confident factoring. I often have students say that they hate factoring, they don't understand it, but it's just a matter of learning it, learning the different techniques you use depending on what kind of expression you have, and doing examples so that you understand it. So take care, and we will see you on the next video.